Now let's talk about the behavior of the tangent line itself, or the behavior of the derivative as we move from left to right. So that's kind of thinking about two tangent lines and how the slope changes from one tangent line to a nearby one. So I would say if the slope of the tangent line is increasing, so what that's saying here is that this tangent line has a positive slope, and this tangent line has a larger positive slope, so the slope of the tangent line increased from this tangent line to that tangent line, then the original function is concave up. So would you agree that this function is concave up from here to there, roughly? Now, a function can be concave up basically just at one tiny point. We don't have to go all the way into the future, or this far into the future. But our point here is that when we're tracking the movement of a point along the curve and the tangent line is getting steeper and steeper, or more and more positively sloped as we're moving along, that means the original function, this blue curve, is concave up. So then what if we move over here? So here, from this point to that point, the slope of the tangent line gets less positive, so the tangent line, the slope of the tangent line is decreasing. Even though the tangent line itself, both tangent lines are increasing, the slope as I move from here to there is decreasing. And that's where the original function is concave down. That's where the original function is concave down. And we can see that because the derivative in that region is decreasing. Here the derivative is decreasing and positive. What if we move over here? So here, the slope of the tangent line gets more negative, so the slope of the tangent line is decreasing, and the derivative values are decreasing. Here they're negative, here they were positive, but we're still on a concave down part of the curve. And then once we get over here, the slope of the derivative, let's move this one. Here the slope of the derivative is negative, fairly strong, and as we move farther to the right, the slope gets less strong, less negative, so the slope is increasing, even though it's negative, and we are on a concave up part of the curve, even though the derivative is currently negative. So it might be good to write out this exact sentence. If the slope of the tangent line is increasing, then the original curve is concave up. And write it again as if the value of the derivative is increasing, then the original function is concave up. So notice here we're, unlike the previous video, we're talking about how the slope of the tangent line is changing from one point to another, but we're not talking about whether f is increasing or decreasing. We saw this region is concave up, even though f is decreasing here. Over here, f is concave up and f is increasing.